Okay, these notes are electron configuration notes. Okay, if you remember from electrons and atoms, we talked a little bit about principal energy levels and sublevels and orbitals. We're now going to go into a little more detail on all of those because that's how electrons fill up. Now, if you remember, Schrodinger was the one who figured out that electrons, yeah, they're in energy levels, but they're also in different sublevels with orbitals. Orbitals are basically the paths that each electron takes. So I guess the best way to do this is to draw a picture. So we're going to draw a few, because I had a picture like this, I think, in the notes from electrons and atoms, but we're actually going to draw it ourselves. Oh, it's skipping. Don't know why that's happening. Okay, so pretend like, or think about this as a stadium, and you're entering the stadium, and depending on where you're going, where you're sitting, there's a certain amount of seats. So if you're down in the first row, there's only one seat, and it's labeled S. Now, if you can go up one more level, there's two seats there, an S and a P seat. And then on the third level, going up a little higher, there's an S, a P, and a D. And then if you go up even higher, there's room for more seats. There's the S seat, the P, the D, and the F. And that's basically what's happening in atoms. There's less space. The closer you get to the nucleus, the less space there is. So if you remember, the S were the circular orbits. So they just kind of travel around in a circle. And then when they get up to the next one, there's the circle, and then there's those dumbbell shapes, the PX, the PY, and the PZ. One of the things that you need to realize is that electrons are kind of like human beings. We don't really like to expend as much energy. So we'll do something that expends the least amount of energy possible. And that's what electrons are. They want to go into the principal energy level and the sublevel that has the lowest amount of energy. So if you think about it, electrons are negatively charged. And what's in the center of an atom but protons? Protons are positively charged. So there's that attraction there. So while those electrons are circling that nucleus, it's also being helped around by that positive charge, that attraction to that positive charge going around it. So in essence, the protons kind of push the electrons around. So the closer you are to the nucleus, the less energy that is needed in order for those electrons to move. The further out you go, the more energy. So those electrons are going to fill in from the closest to the nucleus on out that way. So now we've got our principal energy levels are the 1, 2, 3, and 4. And then our sublevels are the S, P, D, and F. But notice something. There's an S on every level. There's a P on the second, third, and fourth level. There's a D on the third and fourth level. And there's an F on the fourth level. And by the way, the fifth, sixth, and seventh levels, and there are 7 principal energy levels, they're all the same as the fourth one because there's only 4 different types of sublevels. So we need a way to distinguish between them. So we just stick the number. So if we're talking about the S sublevel in the first principal energy level, we're talking about the 1s. If we're talking about the S sublevel in the second principal energy level, we're talking about the 2s. And then there's the 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Okay, so keep those in mind. That's when we do the electron configuration, we're going to be talking about what principal energy level is it going in, what sublevel is it going in when it fills up. Okay, so that's how we indicate it. Okay, so we're going to look at sublevels, orbitals, and total electrons. Now, one of the things is there's 2 electrons per orbital. So only 2 electrons can go into an orbital of a certain sublevel. Now, if you remember from the electrons and atom notes, you found out the S sublevel, which is a circular sublevel, basically has one orbital, one path, one circular path that those electrons can follow. Okay? When you get to the P, if you remember those dumbbell-shaped ones, there was a PX, which was the horizontal one, PY, which is the vertical one, and then the PZ, which is the one that came in and out. Okay, so there's 3 p orbitals. Now the s, or one orbital, so there's only 2 electrons that can fit in any s sublevel ever. In the p's, you can fit a total of 6 electrons in the p sublevels. Now, whoops, this is backwards. This is D and this is F. The D had 5 different orbitals, which means 5 different paths that those electrons could follow. And if you have 2 electrons in each path, then you've got a total of 10 electrons. F had 7 orbitals, so there's 7 different paths, which means there's 14 total electrons that can fit into an F sublevel. Now, think about it. Electrons are negatively charged. So how the heck do 2 electrons get into one orbital? They're pretty close to each other in that orbital. You know, they're flying by each other. They're relatively close enough where a negative charge is going to be going, this ain't going to happen. So it's pushing it out. So there's got to be some other force that keeps those 2 electrons in that orbital, and there is. Okay, it's called the magnetic force because electrons spin. One of the things, if you took ICP, you remember that if you have an electric charge, well, not only that, but you can have a magnetic force. So when electricity or electrons spin, depending on which way they're spinning, they generate a magnetic force with the North Pole facing either up or down. Okay, so one electron will spin clockwise. Now, we denote that with an arrow up, and that means that probably the North Pole is facing up. Okay, so you've got an electron where the North Pole is facing up, okay, and the South Pole is facing down. Well, now comes this electron, and it's going to see, oh, you're spinning clockwise. Well, oops, stop. So it's going to stop spinning clockwise and start spinning counterclockwise. So when it spins counterclockwise, so it's spinning the opposite way. So because it's spinning the opposite way, its magnetic poles are going to be opposite. So your North Pole is going to be facing down and your South Pole is going to be facing up. And that is the only way you're going to get 2 electrons in one orbital. Okay, so when electrons fill orbitals, they do so from the lowest energy to the highest energy. Now, generally speaking, S orbitals have the lowest amount of energy, then the P, then the D, and then the F. So your S gets filled first, then P, then D, then F in each principal energy level. That's not exactly the order they go in. They do, but it's a little more complicated than just that. And you'll see that in a minute. But if you look at each principal energy level, that is the order that they're filled in. Okay, now before we actually start doing a filling order, we need to look at orbital diagrams. So it's how we show that the electrons are filling up the orbitals. So if you remember, S's have 1 orbital. So we're going to make 1 block. Okay. P's have 3 orbitals. So we're going to put a rectangle with 3 blocks in it. And then D's have 5. So 1, 2, 3, 4. Okay, so we're going to show a D with 5 blocks in it. And then the F with 7. So 1, 2, 3, 4, 5. Oops. Okay, hang on, guys. Come on, get to the eraser. I am not very good at drawing these things. Okay, so 6 and 7. Not the best artistic. 4, 5, 6, 7. Yeah. Oh well, who cares? Okay, and then we're going to put arrows either up or down to represent the electrons in each orbital. Okay, so let's look at the electron filling order. First off, I'm going to redo this part. If you remember from the little stadium we drew in the very first slide here, the 1 represents the principal energy level, and the letter, the S, the P, the D, or the F, represents the sublevel. So when we fill these, we're going to be filling starting with 1s, which is your lowest energy. Okay, now remember, in the first principal energy level, there's only an s, period. There's nothing else. Then you get to the next one, you have your 2s and 2p, because if you remember, there was a 2s and a 2p. Then we got to the third energy level, and there's an s, a p, and a d. Well, we do put electrons in the 3s and then the 3p, but not the 3d. It actually has a little more energy than the 4s. 4s has less energy. Okay, so I'm going to put the highest energy here. So, as I said, it got a little complicated at this point in time. So we go 1s, 2s, 2p, 3s, 3p, and 4s. Now let's look at the total amount of electrons, because when we're doing electron configuration, we have to account for every single electron. Now this 1s is going to have 2 electrons. This 2s can hold 2 electrons. The 2p is going to hold 6 electrons. 3s is going to hold 2 electrons. 3p is going to hold 6 electrons. And the 4s is going to hold 2 electrons. Okay, so that's a good start. Let's keep on going. Let's actually go to our next slide. Okay, so let's do the complete filling order. So we're going to start with the 1s, and then we're going to, oops, I don't need to write a comma. Used to write commas all the time, but we don't anymore. Okay, then we do the 2s, then we do the 2p, then we do the 3s, and then we do the 3p. And we should do 3d, but we don't. We actually stick a 4s in there, then we do the 3d. Okay, now we're going to do the 4p, and then comes along 5s, and instead of sticking the 5p, we do a 4d. Okay, and then a 5p. Okay, so that's fine and dandy. Now we hit the 6, so we do 6s. At this point in time, we actually go into the f orbitals. So we have a 4f, and then a 5d, and a 6p. And then we have a 7s, 5f, 6d, and 7p. And that's actually where it ends. That takes care of every single known element on the periodic table. Now, if you notice, there's still room. So if they do come up with a new element, that would go into an 8th energy level. And then we would have an 8s. And it would be an 8s and then a 7d. Or actually, it would go into 6p. Or no, 6f, sorry. 6f and then 7p and then 8, or 7d and then 8p. But we don't. Okay, so this is it. This covers every single element that's known to man and that we've made so far. Now there's a little chart, a little handy dandy little chart I'm going to show you that might make it easier than having to try and follow this. Okay, so you're going to write down 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d. Now notice I'm not writing a 6f because there is no such thing. And then 7s and 7p. And that's where I'm stopping because there are no orbitals after that. Now, what you're going to do is you're going to take a little line. You're going to go through here, and then you're going to go here, and then here. Now, notice what's happening. I went through the 1s first. Then I took a line, and I went through the 2s. And then I took my diagonal line. Oh, wow, I went through the 2p and 3s. Now look at my diagonal line. I'm going through the 3p and the 4s. Now my next diagonal line goes through the 3d, the 4p, and the 5s. Then my next diagonal line is the 4d, 5p, 6s. Then my next diagonal line is the 4f, 5d, 6p, and 7s. Then our next one is the 5f, 6d, and 7s. Now let's check it, make sure it matches up there. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. So it works. So you can either do one of two things. You can either have this whole list written out somewhere for when you do the electron configuration, or you can do this little chart. It's up to you. When you have your test in Unit 3, if I let you use a cheat sheet, which most likely we will, you can have either one written down. It won't matter. Okay, so let's get down to it. Let's actually do some electron configuration. Okay, so let's look at the electron configuration of hydrogen. Hydrogen has one proton, which means it has one electron. If you remember from the structure of the atom notes, every single atom, every single element out there in its normal ground state, regular atoms, has the exact same number of electrons as it does protons. That's because they're electrically neutral. So if hydrogen has one proton, it has one electron. So I'm going to draw my box. Now, 1s is the first sublevel that is in an atom. So hydrogen only has one electron, so it's going to put one arrow in there. So its electron configuration is 1s1. Okay, so this is our electron configuration. What we're doing is we're writing down which sublevel and how many electrons, that superscript is how many electrons are in that sublevel. Okay, and in this case, it's an S, so it can only hold up to 2. It's 1s1 because there's only one electron. Okay, so I'm going to tell you this is the electron configuration. Okay, because the boxes are the orbital diagrams. Okay, so helium is the next one, and it's 2. So we start out with the 1s sublevel, and we're going to put both our electrons in there, because if you remember, each orbital can have up to 2 electrons. So we're either going to put 1 arrow or 2 arrows in there. Now, the electron configuration of helium is 1s2. Let's look at lithium. Lithium has 3 electrons. Well, we're going to start with the 1s. We're going to put 2 electrons in there, but we still have 1 more electron. So then we're going to write the 2s, and we're going to put that next electron in there. So the electron configuration is this. So there's 2 electrons in the 1s, and then there's 1 electron in the 2s. Okay? So let's go on to the next one, which is beryllium. Beryllium is atomic number 4, which means it has 4 electrons. So beryllium starts out with the 1s, puts both the 2 electrons there. Now it has the 2s, and if it's 2 more electrons, well, guess what? We've just taken care of its 4 electrons. So this is 1s2, 2s2. Okay? So let's keep on going. Okay. The next one is boron, which has 5 electrons. So we're going to do the 1s. We're going to put the 2 electrons in there. And then 2s is the next one. We still have 1 more electron. Now, the next sublevel, however, is not an S, but it's a P. So it's the 2p. So yes, we have to draw all 3 boxes because it's a p orbital. It has 3, or it's a p sublevel. It has 3 orbitals. And we're just going to put the electron in the first one. So this electron configuration is 1s2, 2s2, 2p1. Okay, now let's try carbon. Carbon has 6. So we're going to draw the 1s, put 2 electrons in there. 2s, I'm going to put 2 electrons in there. And then I'm going to do 2p. Now, it's got 2 more electrons. Now, notice what I'm going to do here. I don't have the 2 arrows next to each other. And that's because electrons don't want to be in the same orbital if they don't have to be. There are 3 orbitals in the 2p. So those 2 electrons, they don't have to be in the same one. So they're not gonna, okay? Kind of like if you're on a roller coaster and there's a car with 3 seats in it, okay? If you don't know the person that's behind you, you're not going to sit next to them if you don't have to. You know, if that person can sit in one seat and you can sit in another row in that seat, you're going to do that. And you're not going to sit right next to that person. Okay, so that's what electrons, they don't want to be in the same orbital. So our electron configuration is 1s2, 2s2, and 2p2. Okay, let's keep on going. Okay, at this point in time, let's do nitrogen. Nitrogen has 7 electrons. So we're going to do the 1s with 2 electrons in it. Then we're going to draw the 2s, put 2 electrons in that. And then we're going to draw the 2p. Now there are 3 electrons. So they're all going to go in their own separate orbital. They're not going to sit next to each other. So then we have 1s2, 2s2, and 2p3. Okay, oxygen has 8. Now we're going to do the 1s. Then we're going to do the 2s. Ugh, I don't know why this keeps missing. And then we're going to do the 2p. Now at this point in time, there are 4 more electrons. So it's going to fill up like this and like this. And then that 4th electron, unfortunately, he's going to have to go into an orbital with that already has an electron. So it's going to have to reverse its spin and then go into one of the other ones. We always just stick it in the first one just to show you. I mean, you could put it really in the middle one or the end one, but please don't. Just stick it and just do left to right. That way we keep it consistent. So it's 1s2, 2s2, 2p4. Okay, we have fluorine, which is 9. So 1s. Then we have 2s. And we're going to draw this. 2p. So we're going to put our first 3 there, and then there's 2 more. Okay, so it's 1s2, 2s2, 2p5. And our last one, let me put this up a little bit. If it will move, I guess not. Okay, our last one is neon. And neon's 10. So 1s with the 2 electrons. Then the 2s with the 2 electrons. Now, we have 6 more electrons. So you might as well go ahead and just put an arrow, 2 arrows in each box for the 2p. Okay, so this is 1s2, 2s2, 2p6. And that's pretty much the first 10 elements. Okay, let's try to do some more complicated ones. Okay, so at this point in time, let's try bromine. Bromine has 35 electrons. Now, I'm not going to make you do the orbital diagrams with this. Usually, we don't do the orbital diagrams, maybe up to the first, 20 possibly. But they're a pain in the butt to do, so I don't know. You might have to do a few of those, but you're not going to have to do too many of the orbital diagrams. Okay, so I'm going to show you how to do it without doing the orbital diagrams. Okay, so we're going to count electrons as we go. We know that there's 35 electrons that we have to put in there. So I'm going to write down, now I just showed you with neon, up to neon, there's at least 10. So we can actually write that electron configuration, and we've accounted for 10 of them. So we're going to do 1s2, 2s2, 2p6. So at this point in time, we've got 10. We've got 15 more that we have to deal with. So let's add 3s2. So that's 12 more. Okay, and then we'll do the 3p. That can fit 6. So we're at 12. We're at 18 right here. Okay, so we're getting there. Okay, after the 3p, if you look on your chart, it's 4s. And of course, the s can only hold 2. So we've now done 20. We still have 15 more to go. Okay, after the 4s, though, is the 3d. So we can put 10 of those. We've now accounted for 30 of them. So that means your last one's a 4p. Now, p's normally can hold 6, but we only have 5 electrons. So we've just used 35 electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. That's the electron configuration for bromine. Okay, so let's try zirconium. Now, zirconium has 40 electrons. So I know for sure that it's got, if you look above it, I know I can write all of that up until the 4p because there's at least 35 electrons in it. So I'm just going to go ahead for expedience sake and write down 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now at this point in time, I know that I have covered 30 electrons here. Okay, so my next one would be the 4p6 because p can hold 6. I've got 36 electrons. I still have 4 more to go. So after the 4p is the 5s, and that can fit 2 electrons. So I'm going to put a little 2 up there. I've now done 38. Well, after the 5s is 4d. So now I'm going to write 4d. But since I've only got 2, I'm going to put the 2 there. And that gives me 40. Okay, so that's the electron configuration for zirconium. Okay, so let's do lead. Lead has 82 electrons. So I'm going to start out with what I know. 1s2, 3s2, 3p6, 4s2. I know that that's 20, which means I still have 62 left to go. That's just something I've memorized. Calcium is the 20th element, and that's calcium's. So it's the only one that uses S's and P's and no D's. After calcium is where you get into the D's. Okay, so let's do this. So if we do 3d10, okay, we now have 30. So we have 52 left. Okay, then comes 4p6. And I'm just going to add, because there's 52, so I know I can add a few of these without actually counting each one. 5s2 and 4d10. Now, at this point in time, I have added 18. So I'm going to take 30 plus 18. So I'm at 48. Now, 82 minus 48 gives me 34 electrons. So I still have 34 more to go. Okay, so let's go on. Let's keep on going. Okay, so after the 4d is 5p. And I know that's 6 in there. And then 6s2. And that's where I'm going to stop right now. So that's 48 plus the 8. So that's going to be 54. Or no, 56, right? Hang on. 48, 49, 50, 56. So we've got 56 electrons there, which means we have 82 minus 56 is 26 electrons to go. Okay? So the next one after this is where we get into the F's. So we're going to put 4F, and because 14, I know I have at least 14 electrons, I'm going to put a 14 up here. Now that tells me I have 70 electrons, right? 50, 60, yeah, 70. So I have 12 left after this. Well, after the 4F is the 5D. So the 5D, there's 10. So I have 80, and I have 2 left, which means my next one is 6p2. And then I've used up all 82 electrons. And that's lead. In the next couple of days or so, well, the next set of notes will be electron configuration with noble gas shorthand. And it's a little bit easier than this, but you have to understand the full electron configuration before you can understand how to do the shortcut. But there should be some practice problems on this, so get to work on them. If you don't understand them, then you can go back and look at these notes again or just ask me. But until next time, bye.